Okay, I hope you are all doing well, guys. Today I'm gonna talk about clinical anatomy again, neuroanatomy, and I'm gonna talk about the Olivospinal and the Spino-Olivary tracts. Okay. Before I start, let me just grab my pen, and I would like with a brief description of the Olivo and the Spino-Olivary tracts. So, because they are, you probably know that as all the other structures, they are important components of the central nervous system, and they will play an important and essential role in motor control and sensory processing. And these two tracts consist of both descending and ascending fibers that intertwine as they travel along specific pathways within the spinal cord. And their unique location, which you will see here, and function make them important for understanding the neurocircuit involved in movement, coordination, and sensory integration. Now, about the anatomical location, these tracts are situated in the most ventral frontal part of the lateral funiculus, which is one of the three major divisions of the white matter in the spinal cord. And I already mentioned about the lateral, anterior, and posterior funiculus in other videos. I highly recommend you to have a look on my YouTube channel. And they extend between the olivary nuclei located in the medulla oblongata and the spinal cord itself. This positioning will allow these tracts to serve as a communication bridge between the higher brain centers and the spinal cord, which facilitate the transmission of signals necessary for coordinated movement and sensory feedback. Now, here you can see that I did a very simple, but I think that relevant illustration that will help you to understand better the olivary nucleus and the olivospinal and spino olivary tracts. Okay, so let me just start completing here. Okay, these areas, and I will maybe this pen here. Probably gonna start talking about the dorsal accessory olivary nucleus. Okay, so dorsal accessory olivary nucleus. And this nucleus is one of the accessory structures associated with the olivary complex, and it will contribute to the overall connectivity of the olivary system, which will help to modulate motor outputs by influence the activity of neurons in the spinal cord. Here you will notice the inferior olivary nucleus. Okay, inferior olivary nucleus, and this is the largest and probably the most prominent component of the olivary complex, and it will be important because also it plays a crucial role in cerebellar function by sending projections to the cerebellum via the climbing fibers. And these fibers provide important timing and error signals that will help to fine-tune motor learning and coordination. Here you will find the medial accessory olivary nucleus. Medial accessory olivary nucleus. And this one is similar to the dorsal accessory olivary nucleus. Okay, and this structure will support the functional integrity of the olivary system, and it aids in the modulation of motor commands and sensory information processing, which ensures, of course, that the nervous system can adapt to changing environmental demands. Now here you're going to find the olivospinal and the spinal olivary tracts. Let me just finish this illustration here. I might have to clean a little more this one here, but it's fine. Okay, here we have the spinal cord, anterolateral aspect of the lateral funiculus, okay. So about these two here, the olivospinal tract consists of descending fibers that will originate from the olivary nucleus or olivary nuclei in the medulla oblongata, and these fibers will project down the spinal cord, where later they will synapse with interneurons and motor neurons. The olivospinal tract will be particularly important for regulating muscle tone and coordination, especially the coordination of complex movements, such as those involving walking and grasping. Now, the Spino-Olivary tract will comprise ascending fibers, okay? Ascending fibers that will carry sensory information from the spinal cord back to the olivary nuclei. And this pathway helps especially to relay proprioceptive and other sensory inputs, which allows the brain, of course, to monitor the body position and adjust motor commands accordingly to the specific situation or task. Now, clinically, disruptions of the olivospinal and spino-olivary tracts can lead to significant neurological deficits. For example, damage to the olivospinal tract. So when this tract, when injury affected this tract, what will happen? It may result in impaired motor control, which leads to symptoms such as muscle weakness, ataxia, or spasticity, and conditions like stroke, trauma, or degenerative disease affecting the medulla oblongata can impact the olivospinal tract. Impairment of the spino-olivary tract or dysfunction in the spino-olivary tract can disrupt the flows of sensory information to the brain, potentially causing difficulties in proprioception and which will later contribute to balance problems or gait disturbance. And the olivary nuclei is located in the medulla oblongata and is the lowest part of the brainstem, and this region will serve as a critical, let's say, hub for integrating sensory and motor information, making this area in specific a key area for the functioning of the olivospinal and the spino-olivary tracts. And the proximity of the olivary nuclei to other brain stem structures, which I will show you later in another videos, will also underscore the importance in maintaining overall neural homeostasis. So yeah, guys, this is pretty much the topic that I wanted to share with you. I hope that you can finish now. I can finish these 10 minutes, and you will also finish these 10 minutes with a better understanding of the Olivospinal and the Spino-Olivary tracts. So don't forget to subscribe, to share this video with someone that you maybe know that might needs this topic, to review this topic, or have a different presentation of this topic. Yeah, don't forget to share. Don't forget to share. Okay, make a comment if you think that is relevant for the video. I hope to see you next time. Cheers.